Cool, and back. So, back at subscribe pending transactions. No, that's not implemented. Contract calling. So yeah, you can call a contract. It doesn't send anything to the blockchain. It doesn't need to be mined. It goes instantly, and everyone's happy because you don't pay it. You can run it on previous blocks. So it's pretty much most of the time you're reading the state of the contract, or the contract has functions to read its own state. You can pass block arguments, but because of state pruning, like blocks that are 100 or so old might not be available. Pending call contract does the same thing, but with the pending transactions taken into account. Suggested gas price retrieves the currently suggested gas price to allow a timely execution of a transaction. So if you get a client and you call suggested gas price, call context at hex gas price. So it just currently suggests a gas price. And all it does is it wraps it around this function. That seems interesting. Estimate gas. Tries to estimate the gas needed to execute a specific transaction based on the current pending state of the backend blockchain. To call args message. So you build a message which has your transaction in it, and that's what you're going to submit. And then you call estimate gas, and it will return an integer with how much gas it might cost. And then you get suggested gas price, and you times those two together, and you should be able to get an estimate of how much it costs. I did see an issue on the GitHub about it not working, so I don't know. We'll see. Send transaction injects a signed transaction into the pending pool. So it takes a transaction, encodes it into RLP, ETH send raw transaction, and sends the raw data as hex. To call arg. Takes a message, returns an interface. If message data is greater than 0, arg data. So they're making an interface that's got to from the data, the value, the gas price. And that is all. Takes a message and returns it as a blank interface, so you can read it in whatever function you want. Okay. Cool, so a lot of this rotates around this call context, and also a little bit higher up it rotates around get block, this get block, which actually calls call context 2. So get block, you pass it a method which is a string, and the arguments which is an array of interfaces, so it can be anything, array of somethings. And then they just pass those arguments into this call context. You get a raw message back. So, what's JSON here? It's just regular JSON. JSON.raw message as Golang. Why would that not work? Raw message is an array of bytes, which has marshal and unmarshal on it. So this is just an array of bytes, and you can call marshal and unmarshal on it, which reads it into the JSON encoding of M. Or set M to the copy of the data. Returns M as a JSON encoding of M. M. So it takes the raw message and makes JSON, which I imagine is just strings. They're calling call context again. They get the header and the block out of this JSON that's come back. And quick verify transaction and uncle lists. Debug in the server. If types uncle hash is empty and uncle hash is greater than 0, then there's a non-empty uncle list, but block header is 0. Same deal with so these are just, like it says, error checking to make sure that what's said in the header matches what's in the body. Load the uncles because they are not included in the block response. So it gets uncles for I in batch. In requests, get uncles block hash. Batch element. So the batch element get all the uncles by hash and index. Fill the sender cache of transactions in the block. So what does this actually return? It returns a block. So it just builds a block. It calls and it gets a block, including uncles, including receipts, including the everything, I'd imagine. Maybe not the receipts, but it's definitely got the header. Types new block of header, head, dot with body, transactions and uncles. Cool. And now we're back at everything surrounding this ec.c call context. It's not there. Call contact. Here we go. Performs a JSON RPC call with the given arguments. The context is cancelled before it's returned. Call context returns immediately. The result must be a pointer so that the packaged JSON can unmarshal into it. It can also be nil, in which case the result is ignored. So this starts at 253. Oh, it's quite small. C equals new message method arguments. C method. Let's go up here. Method is get block by number. To block num argument, which is a string, but they've taken a big int and passed it there. Args c.newMessage gives you a message back. They make this operation, which is a request operation. They make a message ID and response. If is HTTP, c.send HTTP. If c.send, cool. Else it just writes it to a file, really. Dispatch has accepted the request and will close the channel when it quits. Switch response equals op.wait context. So they actually block it now. They say we want the response. On this OP, which it's got this channel which will get populated with the response message, I believe. And they call in wait on it. So whatever request ops is, if error equals not nil, if response error does not equal nil, blah. Else, JSON unmarshal response, result, and result. So they're taking a JSON and they're putting it into a byte array. No, they're putting it into result. So result gets passed. Get block has JSON raw message. So it's just a JSON raw message that's getting passed every time. C.newMessage. It takes a method and parameters. JSON marshal params in. And then they call JSON RPC message version 2.0 ID equals that. J.go. What are they calling? Next. Nope. Okay, so here's the structure. RPC dot JSON RPC message has a version, an ID, a method, params, error, result. So has valid ID string, marshal message is notification, is response. So that just really just wraps stuff. It's got the method as a string, it's got the params as a that's a byte array raw message. And it's got an ID and a version, which is being called context. So they call a new message, which is somewhere here, and it is making JSON RPC message, and that's what gets returned, is this structure that's got nothing in it so far. So they got this structure. JSON.raw message ID. And they call send HTTP. It's not there. So they call this send HTTP. Write connection. They get the HTTP connection from the client. Do request context and message. Defer closing the response body. If error does not equal nil, ignore that. Response message, JSON decoder. Ops response equals response message. So they get the message, send the message, and block. Where do they block? Must be in do request. So you get a HTTP connection, taking a message in a context, HC request with context.
I can't show all of your contacts.
Status code, client do request. So they're wrapping it a lot. But this is blocking. So they're just sending a HTTP request. Don't want to delve into that. Cool. So what else is there in Ethclient apart from that? Okay, so they're all calling call context, types.header, which is what gets the response gets put into. Eth get blocks by hash, passing the hash. Call context. They also pass in a false. So that needs get blocks by hash, false. And I guess that just means it's getting one because this is block. Get header block and then extract, pull out the header into there. Yeah, cool. All right, cool. So I'm going to call it there because there's not that much to this one actually. All it's doing is just wrapping some helper functions around the RPC client so you can make the calls relatively easily, which allows you to do some of the beautiful things they're doing here. Generate signatures, crypt. Cool. Righto. Take care.